Clouds on Mars Products, a place where you begin your journey with innovative, visionary, and easy to implement solutions for your business. Did you know that Fortune 500 companies, they lose about $1.4 trillion per year for downtime? That's a shocking number. When you go deeper, you will find out that FMCG companies, mid-market FMCG firms, can pay as much as $5,000 through $15,000 per hour of downtime. And the shocking extreme is the automotive industry that may pay $2.3 million per, mind-blowing, per hour of downtime. All those numbers come from the Siemens True Cost of Downtime report published in 2024. All those topics are the topics of our episode today. This is Clouds on Mars Products. In this series, we talk about real business challenges, some problems that our customers put in front of us, also solutions that we come up with. My name is Marcin Kubica. I'm head of product at Clouds on Mars, and today I'm joined by Patrycja Moc, BI consultant and Microsoft Fabric certified engineer. Patrycja is behind the Orbit, a solution that we will be discussing today. Patrycja, it's so good to have you here today.
Thank you for having me.
So let's reveal the meaning of the Orbit name. It's an abbreviation which stands for Operational Real-Time Business Intelligence and Troubleshooting. And every word has its meaning and you will find out why. But let's come back to the business challenge. I spent more than 10 years in automotive industry. I used to work in the factory. I'm saying hello to my colleagues if they watch this episode. And I remember that one of the greatest fear of automotive industry is a risk that one day we will stop our client, the production line, the OEM production line, and this will be a costly downtime. So we were doing everything possible to avoid this situation. And as I said at the beginning of this episode, indeed, the cost related with such a downtime is enormous. But of course, even small downtimes that do not affect the final customer, so the manufacturer of the cars. So even those small downtimes, they affect the efficiency, financial efficiency of a given factory. So this needs to be avoided. Patrycja, your experience in this regard, can you share some?
Yeah, sure. I wanted to share experience, I would say, from more operational point of view, because I recall particularly two conversations. First was with quality controller from a big automotive company. And he told me actually that often he spends the entire day getting to know what happened in yesterday's shift because of the fragmentation of data coming from separate sources and the need to get the proper analysis. And that hit me because I haven't realized that it can be so time consuming in the era that everything can be automated actually. And from my perspective, from perspective of BA consultant, where I analyze data like all the time, it can be done once and then adjusted a bit, but the data and the analysis should be like available all the time for you. You shouldn't spend the entire day trying to prepare data again, right? So this hit me hard. And the second example is actually from chemical company, where I would say I spoke also with a person who was a quality controller, quality supervisor, and the client told us that they are basing on manual operations and they don't have real-time information. So some error in the production can be unnoticed and lead to multi-million cost of poor quality, as you've mentioned. So this is mind-blowing for me because I didn't realize that such a small accident in the production line could lead to multi-million losses.
Interesting points, interesting observations. When I think about downtime and how to fight with this situation that happens all the time, right, on the production lines, that basically I will mention two strategies. Strategy number one, try to prevent problems from occurring. So we want to have early warning that something is going into wrong direction so we can take actions before downtime really happens. And the second strategy, when downtime happens, then we need to do everything possible to reduce this problem as quickly or stop this problem as quickly as possible. There is yet another element that maybe is not causing downtime, but is causing poor quality rejections from the production line. This is also something that manufacturing companies, they do everything possible to avoid, because the rework, the scrap, all those are additional costs that they want to avoid. And again, early warning may help reducing this element. So to achieve those two goals, avoid problems or react quickly when problems happen, there are two solutions that we have in Orbit. And we want to have real-time data fed to the system, and we would like to be able to analyze this data live, not possible for humans, but we have machines that can do that and have alert whenever there is a problem that needs to be addressed by humans. Patrycja, can you please tell what was behind the concept of Orbit? Why have we started thinking about Orbit? Why have we started thinking about solution for manufacturing?
So we started with our conversations with clients and actually more their operational needs, operational problems with day-to-day operations. And we faced the question, how do we actually address this in a practical way without rebuilding the entire system landscape? Because in many plants, in many factories today, data exists, but it's fragmented. So you have data in machines, sensors, MES systems, sometimes in Excel, sometimes in databases, but it's not really working together. And because of that, problems are detected too late, root causes are hard to identify, and operators often rely on experience instead of data.
Mm-hmm.
And what we wanted to build is something that changes that without requiring a full system replacement. So that's why we came up with Orbit, because at its core, Orbit is about real time monitoring and fast reaction. So we take data directly from machines and systems, process it continuously, and make it immediately available for analysis. And on top of that, we apply analytics, statistical controls, and clear, configurable Power BI dashboards. So instead of just seeing what happened, you start understanding why it's happening.
Very nice. I like the sentence that you included in your intro, that there is a lot of data, but this data is not working together. And really, this data is not helping companies to prevent problems. And this is the whole point about reducing downtime. We want to avoid downtime from occurring. So this is basically one strategy that Orbit helps implement in the production floor. All right. Do you want to show us something, Patrycja?
Absolutely. Well, maybe I will start, as I mentioned, with continuous streaming of data, because when we want to analyze the data, we need to get it from somewhere, right? So the lineage of the data is very simple, because we take the sources, whichever sources you have, then stream it to the fabric, and it lands in appropriate environment for analysis further. And based on that, we are preparing real-time dashboards. As you can see, here is the page where you have overview of what is already in place, what is going on in real time. But I guess we can go to the SPC page, where you can, as a quality controller, you can see what is going on your shift and how your parameters go up and down in real time. Here you can see real-time alerts. I would say that at this point in time, you have temperature and pressure in control, but in the period you're analyzing, there is high alert activity because, as you can see, you're going up and down and the variance is very high. So it can point to problems which can lead to downtime. So now on this screen, you can see that you need to focus on temperature rising and going above the limits on your machine. So this is the warning for you.
You mentioned the SPC rules, and if you allow me, I'd like to show something. There is a very interesting Wikipedia article. So when we talk statistical controls, we basically mean something that is tackled in this article, Western electric rules. So there are certain rules that help humans or machines observe the data points. And well, you need to calculate like the standard deviation, and there are certain parameters that needs to be calculated, and you are observing data points whether they are above or below, or if they are going in the wrong direction. So there are certain rules that can be applied, and they help detect early a situation that soon will cause problems. So that's what we mean by statistical process control. Well, in a nutshell, this is not the point of this episode. We want to show you technical capabilities that can help implement SPC on real-time data.
Yes, and going back to our dashboard and our, let's say, diagnosis that something is wrong with temperature, as a plant operator, you can go to our AI chat and ask it why my machine is heating up. You can see that AI chat is saying hello in Polish, but I actually asked in English and it gave me the answer pointing out to appropriate documentation of my machine. So it's really, really helpful for the teammates, for the operators on the plant.
And if I may build on that, this leads to the second strategy that Orbit helped implementing. When you have a downtime, well, even if you are before downtime, but when you see from your statistical process control that something goes into wrong direction, still machine operators and production teams may have this support from the AI chat to discuss the situation, right? They can grab some knowledge from the manuals, but also from the past events and the root causes that were detected earlier to find potential causes of the problem they are having at hand. And the same can be applied when we already have a downtime, right? The production people may go and consult the AI chat that can grab actually the data information and knowledge from different sources to help build an answer, and then it will be way quicker to fix the downtime issue.
And if you want to dive deep about what is the distribution of your alerts and what is actually happening in your plant, you can go to alerts board and analyze what is happening, which machine, which parameter is out of scope, and in which scenario in the SPC statistics scenarios. So I think that it's really, really important to have this overview and this ability to dive deep and play around with your data.
Fully agree. So, Patrycja, can we talk shortly about technology behind Orbit and why we've decided to use this technology?
Sure. So Orbit is based on Microsoft Fabric, and we used it because Microsoft Fabric as a software as a service platform gives us the opportunity to combine, I would say, every part of the road you're playing with your data and creating the conclusions from it. So, what I mean by that is that Fabric allows you to ingest the data, which is streamed from IoT systems, for example, then prepare it with appropriate notebooks, I would say mainly for SPC statistics, and then At the last page, which is cherry on top, it allows you to create operational dashboards, pretty much configurable, and you can design the dashboards whatever you want just for your needs. And this is operating in real-time dashboards and Power BI reporting. So it's really nice platform for working with your data from end to end.
And indeed, when I think about Orbit and Fabric and everything that you've just said, I think that Orbit gives and Fabric gives a lot of flexibility. Flexibility in terms of integration with various data sources, flexibility in terms of data processing, real time, flexibility in terms of presenting this data on the screen, and also a lot of different ways to send alerts. You can use all the Office 365 ways to send alerts like Microsoft Teams or Outlook, but you can also think of sending those alerts via text messages, SMS. So all this is possible thanks to Orbit. This leads us to the conclusion of our episode, because we would like to invite you to maybe select a process, do with us proof of concept, how Orbit may help you in a maybe very narrow part of your process, see how useful it is for you, and then we can, of course, make a larger pilot, and then we can scale up and cover most of your processes. Patrycja, any takeaways, anything that we would like our audience to remember after this episode? What do you have in mind?
I would say that my key takeaway also from my experience with the clients is that your data is very useful if you know how to use it. And if you know how to prepare it, you can do it once and then use it for, I would say, many, many months or years even, to adjust, to play around, maybe to implement some AI on top of your data. I mean, everything is possible.
That's true. Technology is there. We just need to clarify the business challenge, and we need to select what options we want to use for whatever application. Thank you very much, Patrycja. If you have a business challenge that you would like to share with us, please make sure that you contact either me or Patrycja. You can use our LinkedIn profiles. You can connect with us via LinkedIn. It will be our pleasure to talk with you about your challenges in your factories. And please make sure, let your data make an impact. Thank you very much, Patrycja, for today.